Could wireless energy transmission revolutionize the way we power our world? Maxwell's claims have ignited a firestorm of debate, but is there scientific evidence to support this seemingly futuristic technology? Maxwell's claims of wireless energy transmission are more than just science fiction, they have the potential to reshape our technological landscape. But is it truly possible, and what are the real-world implications? Is Maxwell's wireless energy technology a groundbreaking innovation or just another hype-fueled promise? Join us as we delve into the science behind his claims and explore the potential benefits and challenges. The concept of wireless energy transmission is not new. Its history stretches back more than a century, with figures like Nikola Tesla laying the foundational theories and conducting pioneering experiments. Tesla's experiments with the Wardenclyffe Tower aimed to deliver electrical power without wires across great distances. He envisioned a world where energy could be transmitted through the air, reducing reliance on centralized power grids and making electricity accessible anywhere. Though his project was ultimately defunded and dismantled, it inspired generations of scientists and technologists.
Over the decades, the evolution of wireless technology moved from theoretical experiments to practical applications. Radio waves became the first real-world application of transmitting energy without physical connections. By the mid-20th century, microwave transmission experiments gained attention, particularly for their potential in powering remote applications like satellites. NASA and other institutions explored the possibility of transmitting power from space-based solar stations back to Earth. Despite promising studies, technical and economic limitations slowed progress.
In the early 21st century, the emergence of technologies like resonant inductive coupling and focused microwave beams brought renewed interest. These technologies allowed for the short-range wireless charging of consumer electronics, such as smartphones and electric toothbrushes. Still, long-range wireless energy remained elusive due to issues of efficiency, safety, and energy loss. Then came Maxwell Chikumbutso, a Zimbabwean inventor whose name began circulating in the scientific and tech communities for bold claims about wireless energy. Maxwell introduced a device he called the Greener Power Machine, which he claimed could wirelessly transmit power over significant distances. The device purportedly used radio frequencies to transmit power without the need for physical connections or traditional infrastructure. Maxwell asserted that his technology was capable of powering devices, vehicles, and even entire homes without plugging into any grid. The claims sparked immediate interest and intense scrutiny. Mainstream scientists and engineers were divided, some expressing cautious optimism, others outright skepticism. The idea of harvesting ambient RF energy or transmitting it directly has been studied, but Maxwell's claims pushed the boundaries of what was previously considered possible. Physicists questioned the energy density and efficiency of such a system. Engineers wondered about power loss over distance, the tuning of frequencies, and safety regulations. Critics argued that unless Maxwell's machine demonstrated measurable, replicable output under peer-reviewed conditions, it could not be considered scientifically validated. However, his supporters pointed to demonstrations and real-world applications. Videos circulated showing homes and cars allegedly powered without wires. Local communities and early adopters reported functioning prototypes. If legitimate, such a breakthrough could revolutionize multiple industries. The transportation sector could eliminate the need for heavy and expensive battery packs in electric vehicles. Public infrastructure could become decentralized, with individual homes and villages harnessing wireless energy. In agriculture, remote farms without access to grid electricity could power machinery and irrigation systems. Urban planning could evolve with fewer restrictions due to power cable routing, but the scientific community emphasized a need for transparency.
Without peer-reviewed data, Maxwell's devices remained in a gray area between innovation and pseudoscience. Maxwell responded by inviting researchers to observe his systems. He published specifications and encouraged testing by independent labs. Some early reports showed promise, citing measurable voltage outputs in controlled environments.
Still, major academic institutions and international bodies remained cautious. The technology, if real, needed to be safe, scalable, and consistent. One of the major challenges facing wireless power transmission is efficiency. Energy loss during transmission increases with distance. RF and microwave energy tend to scatter, dissipate, or interact with environmental variables. Shielding and tuning become critical to ensure the energy arrives intact. Additionally, health and environmental safety is a concern. Long-term exposure to high-intensity RF waves has not been conclusively proven safe. There are regulatory hurdles concerning RF spectrum allocation and interference with existing communication systems. Maxwell claimed his systems operated within safe frequency bands and employed shielding techniques to prevent leakage. He also emphasized the adaptive nature of the technology. It could modulate based on distance, load, and obstacles. If proven, these advancements would set his invention apart from previous attempts. His designs reportedly combined resonant magnetic coupling with directional RF transmission. This hybrid system aimed to provide focused power delivery with minimal dispersion. The ability to focus energy beams toward a receiver could enable point-to-point wireless electricity. Such a system could be used to charge electric vehicles on roads without physical contact, or deliver power to drones and aircraft mid-flight, extending their range indefinitely. Even remote disaster zones could receive emergency power without laying cables. Maxwell's company, Seth Technologies, began collaborating with African municipalities to deploy pilot projects.
Reports indicated wireless-powered street lighting in homes in certain regions. These use cases, if scalable, could accelerate development in energy-poor regions. WirelessEnergy could help bridge the energy access gap in rural and underdeveloped areas. Traditional energy infrastructure is costly and slow to deploy. Wireless alternatives could be rapidly implemented with minimal ground disruption. However, scalability remains a question. Can this technology serve a megacity with millions of devices drawing power simultaneously? Maxwell insists the modular nature of his tech makes it scalable, but large-scale field tests and third-party verification are essential. Critics also raise concerns about security. Could power transmission be intercepted or hijacked? Would we need new protocols to secure energy streams like we do with digital data? What happens in the event of interference or atmospheric anomalies? These are questions the scientific world is keen to explore. At the heart of the debate is a vision for the future. If Maxwell is right, wireless energy could mark the next phase in human technological evolution. It could decentralize power and make energy as accessible as Wi-Fi. But if he's wrong, the hype could distract from legitimate innovations. So where do we go from here? More testing, more data, and more transparency. The world is watching Maxwell and the scientific community with curiosity and caution. Whether this turns out to be a modern-day Tesla moment or a footnote in technological history depends on what happens next. Maxwell supporters believe the future is already here, hidden in plain sight. They see his wireless energy as a stepping stone to something even greater. A world where transmission towers become obsolete, where homes no longer rely on power lines, where remote villages leapfrog into the 21st century without massive infrastructure costs. A future where electric vehicles never need to stop to charge, where wearable tech is always powered and solar satellites beam energy directly to Earth. These visions sound grand, almost utopian, yet innovation has often been driven by such dreams. Maxwell continues to develop his technology amidst skepticism. He's reportedly filed patents and worked on licensing deals. Some countries in Africa are rumored to be considering broader adoption.
International investors have shown interest, though cautiously. The lack of standardized testing remains a bottleneck. To gain international trust, Maxwell's system must pass rigorous benchmarks. Independent labs must validate its performance and safety. Until then, it exists in a liminal space between belief and evidence. There is also a geopolitical angle to consider. If wireless energy becomes viable, who will control the standards? Will it be regulated like telecommunications or treated as an open-source protocol? Could it be monopolized by early adopters, creating energy inequality? Will new alliances form between countries to harness and share this tech? Africa could become a global leader in wireless energy. This would shift power, both figuratively and literally, toward a continent long sidelined in technological revolutions. It would also challenge traditional energy giants and centralized grids. Wireless energy could be harder to tax, monitor, or meter. This could spark resistance from incumbents. However, history shows that disruptive technologies eventually find their place. From steam engines to the internet, skepticism has always preceded acceptance. Maxwell's work has already succeeded in one area. It sparked global conversation. That conversation now needs direction. Global standards must be proposed. Pilot projects must be transparent and well documented. Academic and industry partnerships must form to evaluate and refine the tech. Maxwell alone cannot shoulder the burden of proof. The scientific method must now take center stage. We need more experiments, not just demonstrations. More peer-reviewed papers, not just YouTube videos. Public understanding must evolve from awe to analysis. The media should report progress, not hype. And governments must fund neutral investigations. The stakes are too high for anything less. Because if Maxwell is right, we are on the cusp of a second electrical revolution. A revolution that could light up the world in ways we never imagined. And if he's wrong, the lessons learned could still inspire new breakthroughs. In science, even failure is fertile ground for discovery. So let us remain skeptical, but open. Let us test, but not dismiss. Let us question, but not ridicule. For in the end, the truth will not be decided by belief. It will be decided by data. And that data is still being written.